Okay, class, the second lecture is for the normalizations of the wave function. So we already have the wave function, and now we are going to talk about the normalization of that wave function. So it's more or less, it talks about the probability. So if we have a wave function psi and the complex conjugate of that wave function, then the product of these two will give you the probability of finding the particle psi star of psi, which is also being represented by psi square. Now let us similarly, it is being given here. This is a probability and complex conjugated of psi, and you have psi, so it is represented by the square root of the modulus of psi. Now if we want to find out the probability of finding the particle over a small volume, then it is being given by this one. So this is the probability, and d tau is the small volume element. Now once we know the small volume, we can also find out the total probability. So if we integrate from minus infinity to infinity, it will give us a total probability, and the total probability, which means the probability of finding the particle from minus infinity to infinity is 1, which means the probability is 100%. Now for this equation 2 to be finite, this psi must tend to 0 when r will go to minus infinity and infinity. So in order to satisfy that condition, we are going to multiply psi by a constant n. So we are going to multiply it, so we will get it n psi. Now if we substitute instead of psi n psi in equation 2, then we are going to get this equation 3. And from this equation 3, this n is called the normalization constant. So this n is called the normalization constant, and this equation 3 is called normalization condition. So this is a condition. Okay, now let us assume a function psi which is a solution of Schrodinger equation. So we have a differential equation that is a Schrodinger equation, which is a second order differential equation. Let psi be the solution of that equation, and let us consider another function which is psi1. So this is a probability, and we are integrating from minus infinity to infinity over the volume, and let it be n square. So we don't know what is the n square, so let it be equation 1. Now since this psi1 is a positive term, then n square is also a real positive number and is called the norm of psi of rt. So this n square is called the norm of the function psi. Alright, so let us consider another function psi. So this psi is being related to the function psi1 by the relation this one. So psi is equal to 1 by n psi1. But we already know that psi is a solution of the Schrodinger equation. Then psi1 is also the solution of the Schrodinger equation, since it is being multiplied by a constant, only by a constant, that is 1 by n. So we can see that psi is also a solution of Schrodinger equation, since it differs from the solution psi1 by the factor 1 by n, which is a constant. Now if we put equation 2 in equation 1, then we are going to get this one. So I think you need to make a change in your notes. Instead of writing psi1, it should be simply psi. So we are getting this one, and if we further simplify, then we are going to get here 1. So which means the probability of finding the particle over the entire volume, that is from minus infinity to infinity, is 1. So equation 3, the wave function psi which satisfies equation 3 is said to be normalized. So which means any wave function which satisfies this equation, those wave functions are called normalized wave function, and hence a normalized wave function must have a unit norm. So this n should be equal to 1. So if we are talking about a normalized wave function, then the unit norm, the norm n, should be 1. So using this equation, we can solve some problem. So this is the first problem. The wave function of a particle, so this is a wave function, and the limit is from minus infinity to infinity. where C and alpha are constant. This C and alpha are constant, and we have to calculate the probability of finding the particle in the region 0 to infinity. So it's more or less something like this. If it is given from minus infinity to infinity, the function is from minus infinity to infinity, but we have to find the probability from 0 to infinity. So we already have the function, so we will take the complex conjugate of that function. So this C will become C star, and in the exponential term there is no complex number, so it will stay as it is. And we already know the probability is given by psi star psi, and the limit is from 0 to infinity. So we will substitute the values, then we are going to get this one. And since C star and C are constant, they can come out from the integration, so we are left with this exponential term. So what happens is that for simplicity, this exponential term, this type of integration is being given by this type of solution. So in this case, we are instead of A, we are having here 2 alpha square. So instead of A, it will be replaced by 2 alpha square. So once we substitute that, we will get B as C square 1 by 2 root over of pi 2 alpha square. Now, we already have the probability, but since we are getting the answer in terms of a constant C square, so we don't want this constant. We need to find out the value of this constant. So the beauty of knowing the normalization is that once we have the normalized function, then we can easily find out the unknown parameter, that is your C square. So we know that if we integrate a function from minus infinity to infinity, then the answer will be 1. So in that case, we have the psi star and psi is equal to 1. Similarly, we will put the value of psi star and psi. So we have already put it down, and we will solve this integration similarly like before. And since in the upper case, here we have half. Why? Because we are integrating from 0 to infinity. But since we are integrating from minus infinity to infinity, the half term will not be there, okay? And by further simplification, we are going to get here C square is equal to root over of 2 alpha square pi. So what happens is that you have the probability, so which is given by this one, C square half root over of pi 2 alpha square. So instead of C square, we are going to put this value. So we are getting here, substituting C square and the remaining term. So if we cancel out, we are getting here half. So which means the probability of finding the particles, the probability of finding the particle from 0 to infinity is half, which means that is 50%. So the probability that the particle will be in this area is 50%. In a similar way, you can solve equation example 2 and example 3. Thank you.